There are a number of different natural hazards you need to know about. A natural hazard can be defined as a natural event that has a social impact, and this can be damage to property or loss of life. If there are no people to be affected, then it is not a hazard, simply an event that happened. We can have tectonic hazards, such as volcanoes, tsunamis, or earthquakes. We can have biological hazards, where forest fires are involved. Biological hazards involve something that is living. We can have geomorphological hazards. This could be flooding, mudslides, rock slides, any type of landslide, and these can be linked to other things. For example, a landslide could cause a tsunami, or an earthquake could cause a mudslide. We can have atmospheric hazards. These could be wind-related, such as hurricanes or tornadoes. It could involve lightning, or it could involve rain. Lots of people live in areas that are very risky, for example, around the tectonic plates. So the question is, why do people knowingly put themselves at risk by living near hazards? It could be that they simply don't want to leave. They may believe the defences will protect them, or they just don't believe that the hazard is going to occur. It could be to do with the economy. They might have jobs in the local area. The local area might have very good facilities. There are lots of social reasons people live in hazardous areas. They might not know where to go. There might be language barriers to them leaving. There are lots of human factors that affect the risk level. For example, the risk of flooding. Fertile silt is good for farming. It provides good land. It provides good nutrients for the crops. So people will live near to areas of rivers that are liable to flooding. The cost of land or availability of housing means that people have to live sometimes in areas which aren't necessarily very desirable. They can only afford to live up the top of a mountain. And this will put them at the risk of landslides. Human activity has a big impact on climate change. Humans are responsible for the majority of the CO2 that is put into the atmosphere, and this is increasing year on year. And climate change is leading to more flooding, more extreme weather events. If a densely populated area is affected, then more people are going to be affected. If an earthquake happens in Tokyo, where lots and lots of people live on a tectonic plate line, then more people are going to be affected than if that same earthquake happened further up the tectonic plate line in a less densely populated area. The tectonic plates move around a lot, and these are all parts of the crust of the Earth, the surface that we are actually on. This is a very, very thin surface in comparison with the thicknesses of the different layers in the Earth. Next layer down is a very thick layer. This is the mantle. This is full of magma, molten rock that is flowing very slowly. And then on the inside is the core, which is very, very hot. The heat of the core underneath the molten rock sets up convection currents in the magma. And we have constructive and destructive plates. These plates are constantly moving as the crust sits on top of the magma. Some of them are moving away from each other, some of them are moving towards each other. Now, the blue dots you can see are where we have a high frequency of volcanoes, and you can see that they correlate very closely with a fault line. Earthquakes do as well, dotted around, not necessarily in the same place as volcanoes, because it depends on the type of interaction going on between the plates. But again, these are commonly found at fault lines where two plates meet. There are two different types of tectonic plates you need to know about. The oceanic crust is very thin, and a continental crust is very thick. The oceanic crust is less dense than the continental crust. When two plates meet, there are three different things that could happen. We can have a destructive or a conservative or a constructive. If we have a destructive plate margin, we are going to have a continental plate meeting a continental plate. If this happens, there is going to be no subduction of the plates. The plates will collide and they will crumple up to form mountains. The Himalayas are an example of this happening. Earthquakes will frequently occur when this happens, but you will not find volcanoes in this situation. We can also have a destructive plate margin when we have a continental plate meeting an oceanic plate. Now you've got to remember the oceanic plate is more dense than the continental plate. So the dense oceanic plates will be subducted below the continental plate. As the oceanic plate is taken down towards the hot mantle, the rock that it is made up of will move downwards and will melt, and this will become part of the mantle. This will become magma. The new magma can then pop up over the other side on the continental plate because it is a less dense fluid, and this will form volcanoes. Fold mountains often occur here, the Andes being one example. Friction between the two plates as one goes under the other, friction of them rubbing against each other can lead to earthquakes as well as the volcanoes that are seen in the same location. Where we have a conservative plate margin, we are going to get two plates moving against each other, sometimes in the opposite direction, sometimes at different speeds in the same direction. Friction occurring as the two plates rub against each other will lead to earthquakes. One example is the San Andreas fault line, where we have the slow moving North American plate moving in the same direction as the faster moving Pacific plate. Friction and stress can build up over a long period of time, and this can lead to earthquakes. But you are not going to see volcanoes. In a constructive plate margin, we are going to have two plates moving away from each other in the opposite direction. When they move away from each other, they leave a gap, and the magma below, the magma in the mantle, which is exposed as the crust separates, can reach the surface and is cooled down. This is going to form new rocks. When this is on land, this can lead to the formation of a rift valley. The lava is cooled slowly and can sometimes reach very long distances before it is cooled down into rocks. These can form structures such as shield volcanoes. Or volcanic islands such as the Azores can also be formed by this slow cooling lava. A stunningly beautiful example of this is the Mid-Atlantic Ridge. Underwater, so you can see the rocks cooling quicker than they would on land, and you can see the plates separating. There are a few key words that you need to know. Primary effects are the first effect of a natural hazard or event on the population, that is the people or the buildings. Secondary effects are the after effects of a natural hazard or event. These are going to happen over a longer time scale. This could be days, weeks, months, or even years. The immediate response to a hazard is how people react straight away. This is as the event is happening and the immediate timescale afterwards. The long-term response is how people will react to the natural hazard in the weeks or the months after it has happened. A HIC is a high-income country. This has been defined by the World Bank as a country where the gross national income, GNI, is over $12,000 per person. A low-income country is a country where the gross national income is less than $12,000 per person. We are going to compare two high-income countries where there was an earthquake. We're going to look at Chile, where the earthquake measured 8.8 on the Richter scale, and Italy, where the earthquake measured 6.3 on the Richter scale. The earthquake in Chile occurred in February 2010, and the estimated cost of this earthquake came in at around $30 billion. Some of the primary effects include the airport and the port being severely damaged, limiting transport and supplies. There was a loss of power, which affected communications, affecting how quickly aid could be delivered to the right place, and affecting the supply of water. Unfortunately, 500 people were killed, 12,000 were injured, and many homes and schools were destroyed. The earthquake in Italy in April 2009 had an estimated cost of $11 billion. It was a very old part of the city with lots of very old buildings, and nearly 15,000 of these buildings collapsed, including the university, the hospital, and some very old churches. This earthquake occurred very early on in the morning, which meant the majority of people were still at home in bed asleep. Unfortunately, though, 300 people were still killed, and there were 1,500 people injured. The earthquake in Chile quickly led to tsunamis, landslides, and fire. Now, these tsunamis didn't occur in Chile, they occurred in other countries. The landslides meant that roads were damaged and blocked, which would prevent the supply and the delivery of aid to the appropriate locations. Again, in Italy, there were landslides, this time mud and rock. Due to the large number of buildings that were damaged, Italy saw an increase in rent and house prices, and there were less businesses in the area. Chile had national funding appeals, and local and international emergency services came to the aid of the people in Chile. Repairs began immediately, but would take a long time. Due to the large numbers of buildings that collapsed in Italy, the search for survivors began within an hour. Hotels and tents were provided for people that didn't have anywhere to live anymore, didn't have anywhere to sleep, and Italy suspended bill payments for the people that had been affected. And there were funding appeals in Italy to help the people that had been affected by the earthquake. The long-term response to the earthquake in Chile were the government helping to rebuild a lot of homes, businesses. Italy reduced the amount of taxes that people affected had to pay. Our low-income country case study for an earthquake is Nepal, and this earthquake happened in April 2015 and measured a 7.9 on the Richter scale. The estimated cost of this earthquake was $5 billion, and the aftershocks of this earthquake were felt later on. The supply of food, the supply of water, and electricity supplies were badly affected by this, reducing access to food, water, and electricity across the country. Unfortunately, there were 9,000 people who died due to this earthquake. There were 1,700 who were injured, and 1 million were made homeless, as schools, hospitals, as well as homes were destroyed. Secondary effects included an avalanche on Everest, which killed people, 19 people. Landslides, which blocked the roads, which hampered the delivery of aid and hampered the rescue efforts. The avalanche on Everest meant that the country lost a large chunk of its tourism as people couldn't climb it. There was also a loss of seed that had been stored for planting next year when the homes and buildings were destroyed. Aid and help were pledged from other countries as they sent people and supplies to help sort things out. People that were displaced and made homeless, this 1 million homeless, were given tents to shelter. And because of the landslides blocking the roads, helicopters were needed to deliver the aid and medical supplies that were needed. The long-term response is in relation to the massive rebuilding project that needs to be undertaken and the ongoing repairs that are needed. The repairs to Everest Base Camp will mean that tourism can restart. There are people every day who are continually living with the risks from various different tectonic hazards, volcanoes being one of them. There are a few things we can do to help mitigate these risks. For example, we can do some planning to map the areas that are going to be affected. We can have evacuation plans in place. We can restrict the land usage around the areas. Make sure that not too many homes are going to be built in areas we know could be affected. We can have emergency shelters that are ready and waiting. And food and medical supplies can be stockpiled in case of emergency, in case they are needed. We can educate the people, the population, so they know exactly what to do in the event of a volcanic eruption. It is very difficult to protect against a volcanic explosion. Explosives can be used to change or to try and change the direction of any flow, any lava flow or any other rocks. Predicting volcanic eruptions is easier than predicting earthquakes, easier than predicting when earthquakes will occur. We do get a little bit of advanced warning. And this advanced warning will come from the large number of monitoring systems that are in place. We can look at the temperature of the water in the local area. We can look at the gases that are being released. And we can look at any changes in local gravity. Satellites are going to be a brilliant, incredibly useful tool that we use as part of this monitoring. So they can be used to monitor any ground changes that are going to be taking place, any movements that are occurring. There are people that live in known earthquake zones. These people are at risk from this as a tectonic hazard, but one of the things we can do when we are planning for earthquakes is that we can map out areas to show specifically which areas might be affected if an earthquake occurs. We can make sure that hospitals and other important buildings are situated away from areas that might be affected, so they can be located safely and they can be looked after. Any buildings that are going to be affected can make sure that they have furniture that is fastened down so that any damage that flying around furniture can cause during an earthquake is reduced. We can make sure the local population are well educated about what to do in the event of an earthquake, and we can stockpile food and medical supplies so that they are ready and waiting if they are needed. As part of the school day, as part of a work day, a business day, there might be earthquake drills where people have to practice what to do. As part of protecting against earthquakes, we can reduce the risk. New technology has meant we know more about how buildings can be built, designed so they are earthquake resistant. Predicting earthquakes is much harder than predicting other tectonic hazards as there are no clear warning signs. It is very hard to predict when earthquakes are going to occur. Some people think that animals can sense when earthquakes are about to occur and that their behaviour will change because of it. Smartphones are incredibly useful as they have accelerometers which can be used to minutes before sense when an earthquake is occurring, and they have GPS. Short mental break here to focus yourself before we move on to weather hazards. Here we can see a map of the world, and we're going to be using this to look at global atmospheric circulation. Pressure belts and climate cells are two important factors that affect the world's weather. We have rainy areas, hot areas, cold areas, hot and wet areas, and this is partly due to the tilt, the differences at the equator, and how the sun's rays hit the earth. At the equator, sun's energy is at a 90-degree angle, so it has a very strong heating effect. Whereas at the poles, the sun's energy is much lower. The angle that the sun's energy hits at, so the same energy is spread over a larger area, meaning it will have less of a heating effect. There are some important features that you need to know about the global atmospheric circulation map, where we have descending cool dry air and high pressure, descending cool dry air and high pressure at the poles, rising warm moist air and low pressure. Now the tilt of the earth and the rotation are responsible for seasonal changes in the positions of these cells. They can move north in the summer and south in the winter. Tropical storms can occur in various different locations at various different times. For example, we can have them over here in June and October, hurricanes moving around here from August to October, cyclones moving here in January to March, and then typhoons in May to December. Now, the difference between hurricanes, cyclones and typhoons is all about where they start. Hurricanes are going to start in the Atlantic and the Eastern Pacific Oceans. Cyclones are going to start in the Indian and the Southern Pacific Oceans. And typhoons are going to start west of the North Pacific Ocean. There are a large number of tropical storms each year, roughly 100, and they are going to occur at the intertropical convergence zone. To start, there are a few things they need: a low altitude, a high temperature, high sea temperature, and the sea needs to be 60 to 70 metres deep. There are some different categories of wind speed. So you might have heard of a Category 1 storm or a Category 2 storm. This refers to their wind speed in kilometres per hour. Tropical storms form as the air over warm tropical oceans is heated up, and this air rises under low pressure conditions. As the air moves upwards, it starts to bring with it more air and moisture from the oceans, resulting in strong winds. Coriolis effect, where the air spins round a calm centre. The evaporated moisture condenses, and as it moves upwards, it cools down. As it cools, more moisture is drawn upwards, and we have large clouds forming, leading to large volumes of rainfall. The eye of the storm forms as cold air sinks. The eye of the storm is going to be dry and calm, and winds will move it towards land, where it will stop gaining energy from water. Here we have a cross section through a storm. Starting over this side, if you were here in this position, you would notice that it is starting to get a bit windy, that the temperature will fall and it will start to get cold, and the air pressure will fall as well. You will notice that clouds are starting to form. As the storm moves over you, say we are now here in this position, you'll start to notice heavy rainfall and increased wind. If the eye of the storm is passing over you, you will notice that the eye of the storm is very calm. There is no wind, there is no rain, and it might even be bright and sunny. As the eye of the storm passes, you will find yourself again back in heavy rain and very high winds. You'll notice a sudden temperature drop as the sun goes away. And then as the storm passes, the wind and rain will eventually stop. Climate change, as we see temperatures, water levels and wind change, is that going to be affecting tropical storms? As we see temperatures increase, as we see land temperatures and sea temperatures increase, we are seeing a rise in sea levels. This rise in sea levels can be linked to higher storm surges. The increase in temperature means that air can hold more moisture. It means that with the tropical storms, we are going to see increased rainfall, and then there are going to be more severe floods as an effect of that. We also expect this to have an effect where there's going to be more destructive impact from the storms. That tropical storms are going to be more frequent, and that there is going to be more uncertainty relating to tropical storms, when they are going to occur and how destructive they're going to be. And then we can also see if climate change could have a possible effect on El Niño. Here is a case study for a typhoon which was in November 2013 and first hit early in the morning. This was a Category 5 storm with winds up to 275 kilometers per hour and waves that reached up to 15 meters. 6,200 people unfortunately died as a result of this storm. 90% of Tacloban was destroyed, with an estimated $12 billion worth of damage. And there were hundreds of thousands of people displaced. Land and homes were destroyed. The level of flooding and landslides meant that roads weren't usable. Unfortunately, the fact that the roads were cut off meant there was a delay in delivering of aid to the people that really needed it. A large oil barge ran aground with oil spilling everywhere, and this has devastating environmental consequences. Power, water and food supplies were cut off. This led to large-scale looting as people panicked, as people needed to find something to eat and fresh water. There were damaged crops, which led to future loss of income, and lots of people lost their jobs. The immediate effect was the evacuation of people and international aid being sent. In the long term, there is continued international aid being provided to the people in the area. There is a large amount of rebuilding that is going on, and then when they're rebuilding it with better infrastructure so that the same situation doesn't occur again. They're providing more shelters for future use. There are a few things that we can do to reduce the possible effects of tropical storms. For example, we can plan storm shelters so that people know where they are, so they are readily supplied. We can have disaster supply kits. These can be in every home, these can be in every school, in every building, with the things that people will need in the immediate aftermath to survive. We can educate people so that they know what to do in the event of a tropical storm, and making sure that people have a family plan in place. Where do you go? What do you do? Who do you contact? In terms of protection, storm shutters on windows will reduce the damage. Storm drains and sea walls will protect people. And reinforced doors and walls should hopefully mean that some more buildings survive if this were to happen again. Removal of any trees that could damage buildings will mean that if this happens, there won't be trees to fall on buildings and damage them. The National Hurricane Center in Florida can predict when storms are going to hit land and potentially the impact they're going to have on the level of storms. This can send out a warning to the local people. The National Oceanic and Atmospheric Administration has supercomputers which will take in all of the information about local weather and see if they can take this large chunk of information and use it to predict when storms are going to occur and what will happen. And as we can see in the picture here, that we can monitor them by satellites and aircraft. Here in the UK, we do get some extreme weather hazards as well. For example, we can have snow and extreme cold. 2010, 2011, 2014, 2015. These are due to depressions not passing over as normal. There is a risk to crops and people's livelihood. There is travel disruption. People are going to have the heating on more, so there are going to be increased cost associated with that. And then the risk to health of vulnerable people. Strong winds, which can be the tail end of hurricanes, can cause damage to power supplies, potentially damaging power lines and cutting people off, leaving them without electricity. They can flatten trees, which not only damage the trees, but also damage anything that the trees falls on. And we can have droughts, which is an extended period of low rainfall. So more than 15 days in a row where it basically doesn't rain, or technically less than 0.2 millimetres of rain. This is going to affect crops, it's going to affect water supplies in reservoirs, and again we have a risk to vulnerable people. On the other side of the drought, we have extreme rainfall and flooding. This is going to affect a large number of homes and businesses who could be flooded. There is going to be disruption to travel and disruption to infrastructure, again potential disruption to power supplies. And the heavy levels of rainfall and flooding could cause landslides as a secondary effect. We also need to be concerned about storm surges, flash floods, slow onset flooding and surface water. Thunderstorms can come with heavy rain and wind, the risk of flash flooding. There is the risk, as with everything, of damage to home and infrastructure. There was a large amount of flooding in December 2014 through to December 2013 through to February 2014 in the Somerset levels. This was due to heavy rainfall and high tides. There were storm surges and the riverbed was clogged with years of sediment. There were over 600 homes that were flooded. Local farms were flooded. A large number of homes and businesses, a large number of people had to be evacuated out of the area, and power supplies were cut off. In some circumstances, whole villages were cut off from power, from supplies. Whole villages were isolated by this. A large amount of farmland was underwater for weeks, leading to an estimated £10 million worth of damage to crops. As well as people being evacuated from homes, there was the evacuation of livestock. The floodwaters, the waters that were flooding people's homes, were contaminated with sewage. In response to the floods at the Somerset levels, the rivers were dredged. so that all the rubbish, the dead twigs, the silt that was in the bottom of the rivers was removed. The road levels were increased. Tidal barricades were placed. We are seeing a lot of changing weather in the UK. Extreme weather is becoming both more frequent and more varied, and this is due to climate change, and the climate change is due to human activities. You are doing an absolutely brilliant job with your revision. Well done. I'm really, really proud of you. Now we're going to be looking at climate change. There is a large amount of evidence for climate change. We can see here that there is an increase in global temperature. We have a decrease in global sea ice levels, which is leading to an increase in sea levels. And we have a decrease of land masses in Greenland and Antarctica in land ice. The predominant cause of climate change is human activities, but there are a few natural things that will have a minor effect on climate change. We can have a look at the effect of the tilt of the Earth. It moves between 21.5 and 24.5 over a very long period of time. The orbital path of the Earth, it is changing between a circle and an ellipse. Again, this is happening over a very, very long period of time. And the Earth is not a perfect sphere. It wobbles a bit. Again, this wobble is over a very long period of time. The sun will also have a small effect on climate change. For example, there are sunspots. The magnetic activity within the sun will cause sunspots and dark spots. There are changes in solar outputs, and the sun is working on a roughly 11-year cycle. Volcanoes also put a lot into the atmosphere. Ash from eruptions. The ash can go up into the atmosphere and block out the sun. This can reflect the radiation that's coming from the sun. There are human causes of climate change, and the most well known is probably the greenhouse effect. In this, the short-wave radiation that comes from the sun can pass in through the atmosphere. When it reaches the earth or the sea, it will warm the earth or the sea. The earth then gives off long-wave radiation, and the greenhouse gases in the atmosphere absorb the long-wave radiation. An increase in greenhouse gases means that less heat can escape. There are a number of gases which are classed as greenhouse gases, including carbon dioxide, methane, nitrous oxides, and the really important thing to remember when you're writing the chemical formula things is that you get it right. Little 2 capital letters. Particles from combustion, water, also are responsible for the greenhouse effects, and the gases are going to absorb heat, and the particles in water are going to scatter radiation. One of the primary sources in releasing greenhouse gases, particles and water into the atmosphere is the combustion of fossil fuels. Over 50% of global greenhouse gas emissions are from this one source. This can be in power stations to generate electricity, or cars, trucks and other combustion engines. Agriculture is another source of greenhouse gases, and this is responsible for roughly 20% of global greenhouse gas emissions. Deforestation is removing the trees, which removes carbon dioxide from the atmosphere, and burning of trees can also add carbon dioxide to the atmosphere. Deforestation occurs when we are clearing land for crops or animals, when we are logging for wood, or when paths are being cleared for roads. There are a number of different effects of climate change that you need to know about. Increased flooding, decline in the fishing industry, which is going to be due to rising sea temperatures and lowering the sea pH, the ice melting leading to loss of habitats, and less ice allows for increased access to oil and gas through an increased use of fossil fuels. Tree line moving north, decreased yields of maize, rice and soy, increase in forest fires and an increase in spread of pests, high levels of extinction in the Amazon rainforest, and a change from rainforest to savanna, loss of coral reefs due to high sea temperatures and lowering pH, food shortages, reduced water flow in rivers, increased flooding, increased spread of mosquitoes and thus malaria, increasing drought, heat waves, and affecting the health of the vulnerable. There are a few things that we can do to mitigate climate change. We can have alternative energy productions, carbon capture and storage, replanting trees, and international agreements. Burning fossil fuels to produce electricity accounts for nearly 90% of carbon dioxide emission by humans, so we need to look at alternative energy productions, such as wind, solar, hydroelectric power, tidal, wave, geothermal, and these are all renewable energy sources, and they do not emit carbon dioxide into the atmosphere. Each of these methods has their own individual advantages and disadvantages. 80% of electricity in China is from burning coal, 70% of electricity in India is generated from burning coal, and 50% of electricity in the US is generated from burning coal. With carbon capture and storage, CCS, we can prevent 90% of the generated carbon dioxide from being released into the atmosphere. Deforestation is happening at a rate of 13 million hectares each year. We can plant trees, which will have the effect of removing carbon dioxide from the atmosphere. It will increase moisture in the atmosphere, and this will have an increased cooling effect. In Paris in 2015, there was a climate change conference, and they wanted to keep global temperature increase below 2 degrees above pre-industrial levels. Some countries are more responsible than other countries for pumping carbon into the atmosphere. Some countries can afford to implement the mitigation strategies more than others. With climate change occurring, we need to adapt to it. We need to adapt to the new rainfall patterns, the changes in temperature, extreme events which are increasing, and the change in pest distribution. We need to manage water supplies, so we can start building desalination plants. We can put pumps in villages, and we can put irrigation systems in place. Farmers need to think about moving to new crops instead of ones they have traditionally always farmed, ones that are drought or pest resistant. Wine and coffee grow in very specific temperature climates, so people that used to farm them maybe can't farm them anymore, and there is going to be an increase in new places that can farm wine or coffee. We need to think about reducing the risk from extreme events, for example the Thames Barrier, building homes higher up, and having more coastal defences. I just want you to take a short break here. I want you to do a couple of in-breaths and a couple of out-breaths. Concentrate on your breathing for a minute, and then when you are calm, when you're relaxed, we're going to move on to ecosystems. When we are drawing food webs, it is important that the arrow is eaten by or is showing the direction of energy transfer. Producers get energy from sunlight. Consumers get their energy from producers, from plants. We also have decomposers, which are going to be bacteria and fungi in the soil. When we're thinking about nutrient cycling, decomposers are going to make the nutrients available to re-enter the food webs, so they can take them and make them available again for living things to use. Here we have one of my favourite small-scale UK ecosystems, but there are lots of things that are affecting it at the moment. We need to be concerned about erosion, the effect on food chains that are living in the ecosystem, the effect of extreme weather, the changes to habitats, the changes to nutrient cycling, and then we also need to be concerned about the human impact on this ecosystem. So we can think about conservation projects, and we can think about the effect that development will have on it. One small factor can have many larger knock-on effects. When we are thinking about the factors that affect ecosystems, we need to think about the biotic factors, the living factors, and the abiotic factors, the not living factors. For example, decomposers are biotic factors, whereas sun, rain, and wind are going to be abiotic factors. Soil is another abiotic factor, whereas the insects that you may find in and around it are biotic. Rocks are an abiotic factor, whereas plants and animals are a biotic factor. Biomes are large-scale ecosystems. If we are looking at the tropical rainforest one, they are going to be close to the equator with high temperatures, high rainfall, low pressure, little seasonal variation, a large number of green plants, and they cover approximately 6% of the Earth's surface, but have over half of the world's known species. A quarter of all medicines have originated from plants, animals that are found in tropical rainforests. Deserts can be found north and south of the equator, and these are going to be close to the tropics of Capricorn and tropics of Cancer. They have dry air, they have subtropical high pressure with high daytime temperatures, very little cloud cover, and low nighttime temperatures, and low rainfall. Tropical grassland has dry and wet seasons. This is going to be affected by the movement of Hadley cells. The dry season is very hot, and this can lead to fires. The wet season is very wet, which can have the possible consequences of flooding. Large herds of animals will live in these areas. Temperate grassland is going to be inland, away from coastal areas. They will have hot summers and cold winters. The Mediterranean is going to be the west coast of continents. They have hot, dry summers and mild winters. Deciduous forests can be found at higher latitudes. They are very rainy and have trees that will shed their leaves in the wintertime. Coniferous forests are going to be found in places that have very cold winters, where there is going to be very little sun, and the leaves on these trees reduce the heat and the water that is lost. These trees do not drop their leaves. We have two polar regions. This is the Arctic and the Antarctic. They have very cold air which sinks, very low temperatures, and it is going to be very dry. The tundra is the cold desert areas. There are very low numbers of plants that can be found in these areas. It is very cold, it is very windy, and it is very dry. You are doing amazing work. You have been revising for quite a while now. So again, I want you to pause when you go take a break. Go get yourself a drink, go get yourself a snack, and then come back and we will start on tropical rainforests. Rainforests have a very particular climate. It is very warm with little temperature variation. It is very wet. There are rainy seasons. There are different parts to the rainforest that you need to be aware of, and these different parts behave and look very different. We have the top canopy, the middle canopy, and the lower canopy. In the lower canopy, we're going to have shrubs, rodents, and there are going to be woody creeks. In the middle canopy, there are going to be animals that are specially adapted to living in the trees. And in the top canopy, this is where we are going to find the very fast growing trees. The leaves are going to be adapted so that water drips off them, and the birds are going to feed on the nectar. The soil in the rainforest has to have a few adaptations to support the plant life there, because this is rather infertile soil. There are decomposers in there, for example fungi, and the large amount of rainfall will quickly wash away any nutrients. Tree leaves will fall to the ground. This will be the litter that is on the ground. The nutrients via the decomposers will come part of the soil, and then the trees can quickly take up the nutrients from the soil. Plants are adapted to survive in this poor soil because of the rapid cycling of nutrients. The warm, humid climate is ideal for plants that grow rapidly. Plants in the rainforest have a number of adaptations that will help them survive. They have very shallow roots. Leaves are adapted so that water can drip from them. The top canopy protects the soil from erosion, and only the top layer of leaves, the top layer of plants, will get sun for photosynthesis. Many of the lower plants that don't get the light for photosynthesis get the energy, the nutrients that they need from the soil. There are a large number of plants that have developed parasitic relationships. Animals in the rainforest also have a number of adaptations that they have evolved so they can survive. Food and water is abundant all throughout the year. This means there is a large amount of competition. These animals are going to be specialists at living in the rainforest, and many of them will have specialised to live off one plant. For example, toucans have specialist beaks so that they can break open nuts. Animals that eat the fruit are helping the plant by dispersing the seeds. There is a large amount of deforestation that goes on in the rainforest, and there are a number of reasons for this. Clearing of land for commercial farming, whether this is crops or animals. Mineral extraction from the soil. Again, the trees need to be cleared for the mining operations and for the roads that will allow access for the mining operations. Logging, so that the trees can be used for wood or paper. Roads, so that the various commercial operations can be accessed. The building of homes in areas that used to be rainforest. And the removal of trees for the production of energy. half of the world's rainforest is now gone. It is disappearing at a rate of 1 hectare per second. This is slowing down in Brazil, but it is still going on and increasing in other countries. As with the majority of complex issues, there are positives and there are negatives. Looking at the negatives of deforestation first, there is a loss in biodiversity. 130 species are lost every day. There is the impact on climate change. Trees absorb CO2. Every tree that is cut down means less CO2 is absorbed. And the evaporation has a cooling effect on the earth. Trees protect the soil from erosion. The roots help bind soil together. The mercury used in mining operations is polluting the rivers. The indigenous tribes that have lived in the rainforest are losing their land. And deforestation is leading to conflicts. Differences in opinions, differences in ways of life between the indigenous tribes and the people that want to develop the land. And the loss of plants means that the loss of potential medicines. The rainforest is a big source of tourism, and if it is gone due to deforestation, we have lost the tourists. However, there are reasons that deforestation is happening. It provides a large number of jobs provide taxes. The land can be used for homes and farming and for the development of infrastructure to support the local area. There are several management strategies that have been put in place to protect the rainforest. Conservation and education by NGOs, non-governmental organisations, are focusing on local national parks, jobs for conservation workers, and they are buying up land. There are intergovernmental agreements on hardwood, for example trade restrictions, and registration numbers to prevent illegal logging. Countries are being offered a reduction in their debt in return for protecting areas of rainforest. And an increase in ecotourism. They are using the rainforest as they are to make money. Selective logging means that carefully managing the rainforest can allow them to thrive. And then replanting of felled trees. From this point onwards, we are going to be looking at the options. If you look in the pinned comment, there will be the times for all of these, but you need to look at hot deserts or cold deserts, and then 2 from coastal landscapes, river landscapes, and glacial landscapes. Right, we are about to start hot deserts. I hesitated there because what I want you to do is to write down how many times in this section you think I'm going to say desert instead of deserts, because I'm getting these confused the whole time. There are a number of hot deserts that are dotted all over the world. You need to know the location and the names of these. Now, deserts can be both hot and cold. In this section, we are just looking at the hot ones. They are mainly found between 30 degrees north and 30 degrees south. And the reasons for their climate is a global atmospheric circulation. The lack of cloud cover, the lack of rainfall, means that these areas are going to see extreme temperatures. To survive in hot deserts, the animals, the plants and the soil are going to have adaptations. The soil is very, very sandy, and this is not going to hold water well. Salt deposits are going to have risen to the top due to the evaporation of water. This soil is not going to have much organic matter in it. Plants are going to have horizontal roots that run long just below the surface of the ground. Seeds will have long dormancy periods, and these seeds will rapidly germinate when they find water. Plants can have long tap roots, reaching far down into the ground to get to the groundwater. And leaves of these plants are going to be adapted to retain water and reduce water loss. These plants can also store large volumes of water. Animals can get water from food instead of just from drinking it. They may have light-coloured fur to reflect the sun and thick skin on the soles of their feet so that they don't get burnt. In this case study, we're going to be looking at the Thar Desert in Pakistan and northwest India. The landscape is full of sandy hills, and these are mobile sand dunes. Water, when it does rain, will drain away very quickly. The soil holds very little organic matter, and there is very low rainfall in the area. The economy is based around tourism, mining for minerals, for example gypsum. Gypsum is important for use in cement, and farms that are responsible for producing energy, for example wind farms, solar farms, as well as oil and coal extraction. Farming is part of the economy, but irrigation is needed for this. The challenges of living and working in this area are partly due to the extreme temperatures. It is hard for workers to work for long periods of time in extreme heat. Supply of water is an issue. Evaporation of water when it is around, and plants that are specially adapted to live in these extreme temperatures. There are water shortages. This is an increasing problem as the population in this area and the economy in this area grows. There is a limited road network in the area, which means things take longer to get places, and some places are very inaccessible, which is why the use of camels is still frequent. The Western Desert in the US is actually made up of smaller deserts. There is a large number of people in this area who live in very big cities. The economy relies heavily on tourism, for example in Las Vegas. Farming is a big part of the economy, but again has problems with irrigation. Extraction of minerals is important, uranium for production of nuclear energy, and copper for wires. Energy production from the hydroelectric power produced from the Hoover Dam. The challenges of this area is that outside of the big cities there is very low population density. There are water shortages which are going to be increasing as the population increases. The Hoover Dam provides a large amount of water for the area, but there is a cost to the ecosystem of this. The Hoover Dam provides a large amount of employment, but there is still not enough water to support the local population and the growing local economy. There are also agreements in place with Mexico that they must still allow the Colorado River to flow. When desertification occurs, we have large areas of land who are gradually being turned into desert. The areas at risk are going to be desert fringe areas. These are the areas that surround deserts. There are areas in China, the US, Australia, Africa and Spain where this is happening. The causes of this can be linked to climate change, to natural events, to changes in temperature or changes in rainfall, and they can be brought on by droughts. The edge of the Sahara is seeing a large amount of population growth. They are seeing soil erosion and the effects of climate change. There are a large number of human causes of desertification: climate change, overgrazing, population growth, removal of firewood, overcultivation and soil erosion. With climate change, we are seeing an increase in temperature and a decrease in rainfall. This can be leading to things like droughts. Population growth can be caused by high fertility rates in a population or population movement. Overgrazing can mean that all vegetation in a particular area is eaten and removed. There can be political reasons for this, and there can be farming boundaries which are imposed on normally nomadic tribes. So the nomadic herds, which are used to moving around, moving the herds and grazing different areas, can no longer do this. Overcultivation of crops is exhausting soil fertility, and this can be due to commercial farming. The removal of wood for fuel is removing the root systems, which is leading to soil erosion. Soil erosion, the exposed topsoil, is baked by the hot sun, and when it does rain, that soil cannot absorb the water. The water then washes away the soil. There are a few things that we can do to reduce the spread of desertification. We can plant trees, which means the roots will bind the soil and protect it. The trees will drop leaves. The decomposing leaves will lead to nutrient recycling. We can use appropriate technology. We can put stone walls in place to prevent soil erosion, to prevent soil washing away. We can look at using alternative fuels, so not wood, thus reducing the need to chop down trees, alternative fuels for cooking. Or we can look at technologies which will reduce the amount of fuel needed for cooking. We can manage the water and the soil so that land enclosed by low walls can prevent soil washing away. On hills, we can put traps in place, again to prevent the soil washing away, and we can plant shrubs which will stop soil erosion. This guy looks so peaceful, so happy, so relaxed. That is exactly how you are going to feel in the summer because you've been doing some brilliant revision. Well done. There are two main cold environments that you need to know about: the polar regions and the tundra regions. Polar regions are very cold. There is very little rain or snowfall in this area. The soil is going to be frozen, and the only plants you're going to see are going to be moss or lichen. In different regions, you are going to have polar bears and penguins, or animals that are specially adapted to live in these temperatures. The tundra regions are again very cold, slightly warmer than the polar regions though. They are going to have a short summer, which could be described as warmish. They do get some rainfall, which will allow some trees and bushes to grow. The soil is a permafrost, which can thaw. The soil in these regions is going to be very infertile. Animals you might find include the Arctic fox or the Arctic hare, again who have been specially adapted to live in these environments. Plants can be adapted to live in cold environments. Here we can see some Arctic lichen, and here we have some bear berries. There are going to be a few things that are going to affect plant growth: the permafrost, poor drainage of soils, high winds, poor light conditions. And to cope with these factors, the plants need to have a few adaptations. They are very low growing. They will have thick bark and small leaves. They may have hairy stems, and they'll be very attractive to animals to help with dispersal of seeds. And deep roots will help anchor them. They may be fast growing to take advantage of the short summer period. Animals have also evolved so they are adapted to live in cold environments. Here we have some very cute polar bears, penguins and Arctic foxes. Their fur may be white. They will have thick layers of fat to keep warm. They may have large hooves or adapted feet so they don't sink, and they may hibernate for long periods. For this case study, we are going to be looking at a collection of 5 islands just off the coast of Norway. It is very, very cold there. 60% is covered by glaciers, which means that farming is impossible. There are no trees that grow in this environment. The economy is going to be based around the extraction of coal, around the production of energy, potentially using geothermal power, and the very rich fishing waters in the area. Tourism is also a big part of the economy. They will face a number of challenges. For example, it is very cold, potentially reaching temperatures minus 30 degrees C in the winter. This means it is dangerous to work outside. There is limited light in the area, which means that most construction has to happen over a limited period of time during the short summer months. Pipework needs to be underground to prevent it being frozen, and it is a very remote area, meaning a lot of travel is done via snowmobiles. Alaska is part of the United States, but actually has a land border with Canada and is very close to Russia. It is very cold there. The economy started off being largely based around the extraction of gold, and now is moving towards the production of energy via hydroelectric power and geothermal power. They have very large sustainable fishing operations in the area and a large tourist industry. They face some challenges living in such a cold environment. They have a very low population density outside of the major cities. There is a permafrost, but when this melts, it can cause movement to buildings, roads, or even potential hazards. Buildings have adapted so that they have high-pitched roof so that snow can just slide off. And roads are often built on a layer of gravel to cope with this movement. There are a number of environmental challenges in the area, and these will be linked to oil extraction. The wilderness is a very fragile environment. The vegetation in the area takes a long time to establish. Because it's so remote, it is very unspoilt. Modern developments mean that these areas are now more accessible for tourists and are open to exploitation by large companies. This can cause damage as off-road vehicles may be going into unspoilt areas. There may be potential damage from oil spills, destruction of habitats, and loss of culture. A large amount of infrastructure will be needed to support the tourism and to support companies, and this can have a negative effect on the local ecosystems. There are a few things that have been put in place to help protect these fragile environments: the transatlantic pipeline, the Antarctic Treaty, and a number of conservation groups. The UK has a wide range of physical landscapes. You need to be aware of the location of the major rivers, the major mountain ranges, and the major cities. I know you are slogging through revision at the moment, but I just wanted to pause for a few seconds and think about how amazing it's going to be when you visit the beach in the summer. And you should go and visit the beach in the summer. Take a day off and jump on a train with a load of friends. I love watching waves, and you need to be aware of 2 different types: constructive waves and destructive waves. Constructive waves are going to be low waves. Their crests are going to be far apart. They will have gentle wave fronts. They will spill forward. They will deposit large amounts of sand, and this means there will be longer rides for surfers. Destructive waves are often associated with storms. They are very close together. They will have very steep wave fronts, and they will spill backwards. As a wave moves up the beach, it's going to start off with a circular orbit of water in open water. That's going to be distorted by friction with the seabed. The top of the wave will start to move faster, and then the wave will break. Cliff collapse is due to different types of weathering. We can have mechanical weathering, also known as physical weathering, chemical weathering, or even biological weathering. Biological weathering is going to be weathering due to the effects of plants and the effects that roots have on the cliffs. Chemical weathering is due to acid rain and the rain that's falling, whereas mechanical weathering is going to be due to freeze, thaw, or salt water. Mass movement at the coast is often triggered by rain. Slumping or rotational slip, where we're going to have a concave slip plane. The heavy rocks and the soil are going to fall down that. We can have debris such as mud flowing down, where the wet, saturated soil will slip rapidly down a steep slope. We can have a rock or landslide. This is going to be the breakdown of the cliff due to freeze thaw. Coastal erosion can be due to hydraulic power, abrasion, or attrition. Hydraulic power is destructive waves. As the wave hits the cliff fronts, there can be a change in air pressure as trapped air is pushed or forced into cracks. This increase in air pressure suddenly releases as the wave moves away. Abrasion is a bit like rubbing sandpaper on a cliff, as sand and stones are being thrown against the cliff, and the action of this, the friction of this, is wearing away the cliff. We are going to see this happening more lower down on the cliffs. When pebbles are moving along, they are going to collide with each other. This is going to result in the pebbles having a smooth, round appearance. If a wave hits the beach directly, then the sediment just goes up and down. It will move up in one direction and back down in the opposite direction. When we have longshore drift, it is if a wave hits at an angle. Sediment will move up the beach at an angle, but the backwash is direct to the sea, leaving sand behind. We can get beaches formed in bays, where we have low energy waves depositing large amounts of sand in sheltered bays. Here we are going to have constructive waves forming beaches. We can see lots of examples of coastal erosion on the Dorset coast. When we have headlands and bays, we have different strengths of rocks being eroded at different rates. The weaker rocks, the clay, will be eroded faster than the harder rocks, and this erosion will form bays. The harder rocks are going to be made of things like limestone or sandstone. Cliffs are going to be large protrusions, and the wave cut platforms are going to be at the bottom of these, where we have slow erosion from the bottom, and eventually the cliff will fall down. When we have caves, arches, stacks and slumps, if there is a small fault or crack in the rock, hydraulic action will form caves in that crack, and the waves will make a cave larger until it becomes an arch. The continual erosion of that cave or that arch will eventually mean that the bit over the top will collapse, leaving stacks and stumps. There are a large number of structures that can be formed at the beach. Beaches are formed by deposits of sand or pebbles or small stones. These most often happen in sheltered bays. Constructive waves are going to give us sandy beaches, whereas destructive waves are going to give us pebbly beaches. Sand dunes form around an obstacle. When a large trunk or a large stone is on the beach, sand deposits will start to form around it, giving us an embryo sand dune. Eventually, plants will start to grow on this sand dune, and the effect of the roots on the sand dune will stabilise it. Rotting or organic matter from these plants will increase the fertility of the sand dune, allowing more plants to grow. Spits can be caused by longshore drift. These are narrow sections of sand that reach out into the sea. Bars are formed when spits form across a bay. There are a range of hard engineering techniques that can be put in place. Groins can be built out into the sea to trap the sediments and to prevent it from being washed out to sea. A seawall can be built which will reflect the force of the waves backwards towards the sea. Rock armour are large piles of rock that will break the wave. Or we can have wire cages full of rocks. There are also a number of soft engineering techniques that can be put in place. We can nourish the beach with the addition of sand to a beach, or the movement of sand within a beach. Dunes can be regenerated, or we can create new sand dunes. And when we're thinking about coastal realignment, we can move the population. We can have a managed retreat of the shoreline. Buildings that might be affected can be demolished. Short break here because we are now moving on to river landscapes. When we're thinking about rivers, you need to know the long profile and you need to know the cross profile. The long profile will look at the gradient of the river from the source to the mouth. You need to note the volume and velocity of water, and this is going to increase as you go downstream. The cross profile of the river is going to change as you go downstream from narrow V-shaped valleys to wider riverbed. And this is going to change due to a number of reasons, including erosion and how the river is managed. As a river moves along, it will deposit, transport and erodes parts of it. Erosion will happen in the upper and the middle courses of a river, and this can happen due to a number of reasons. Vertical erosion is going to be downwards, whereas lateral erosion is going to be sideways. Erosion due to hydraulic action is going to be due to the force of the water. We're going to see this where we have fast moving water in large volumes. Abrasion is going to occur where the river load hits the side, dislodging particles. Attrition is where stones knock against each other and they become smaller and they become rounder. And banks can be slowly dissolved. Transportation can happen in a number of different ways, and this is the transportation of the river load. So all the materials that is transported down the river, and this is going to vary by flow and by velocity. This generally happens in the middle course of the river. This can happen by rolling, by hopping, by small particles in suspension, or particles that have been dissolved. Material is going to be deposited in the lower course of the river as the velocity of the water slows down. The large rocks are only going to move short distances. We're going to have large volumes of sediment deposited at the mouth of the river. There are a number of landforms that are formed by river erosion. Interlocking spurs are formed by a river that is close to the source, but it cannot cut through land, so has to go around it. Waterfalls are formed when lower down soft rocks are more easily eroded, leading to a step that the water falls over. And gorges are the gradual moving backwards of a waterfall. Meanders are formed by sideways erosions to the outer side of the bend, whereas sediment is deposited to the inner side of the bend. Oxbow lakes can be formed when meanders move. The necks of these meanders may end up close to each other and join up. Floodplains are wide, flat areas to either side of a river. This is where we're going to find very fertile soil, so it's popular for farming. These can be joined with levees, which are raised riverbeds mainly found on the lower course of a river. Estuaries are going to occur when we have large amounts of material deposited, and these can form mudflats or they can form salt flats. There are a number of factors that affect flood risk. This can be physical factors or these can be human factors. The level of precipitation, the rock type, the steepness of the slopes, or the frequency of the precipitation. Human factors can be how often there is building on floodplains, a common trend for paving over gardens, deforestation, and some farming practices which can lead to things like unused fields, for example crop fields unused in the winter, and the removal of hedgerows. Farms that are on hillsides can also have furrows which act as streams for water to flow down. Flood hydrographs will show us the plot of a river discharge after a storm has happened. Now you know from physics I'm a stickler for my units. Discharge is measured in meters cubed per second, and after a storm, time can be measured in hours or it can be measured in days. It's important to look at the graph. For discharge, you'll likely see a curve. Now there may be two axes on the graph, another one for rainfall in millimetres, showing where the rain and how much rain happened. The lag time is going to be the time from the peak rainfall to the time of peak river discharge. The base flow is the normal flow of the river. You need to recognise the shape of a few different hydrographs. This is a flashy or a storm hydrograph. This is one that will lead to flash floods. This can occur when we have a small river basin, prolonged rainfall, impermeable rocks, a steep-sided valley, high urban land use, little vegetation in the area, and soil that is heavily saturated. Here we have a slow or a flat hydrograph. The peak discharge on this is much lower than a flashy hydrograph. This could be in a large river basin. It has a longer lag time. There could be permeable rocks. Rain or precipitation could be at a very light level in a gently sloping valley that is covered in vegetation or even a forested area. There are a number of different types of hard engineering we can put in place in river systems. Dams and reservoirs can regulate water flow, but they are expensive and they can flood the local area, damaging communities, houses, buildings and habitats. They are a tourist attraction. They can be used to generate hydroelectric power. And importantly, they can control downstream flooding. Flood relief channels are man-made alternative routes for floodwater to go down if it becomes too much for the main river. And this is to prevent flooding. They can have sluice gates on them to further control the river flow. Rivers can be straightened. This will speed up the flow of water to move it quickly away from vulnerable areas. But this may lead to downstream flooding. Embankments can be put in place. This is where you raise the river bank so the river can hold more water. Soft engineering is managing the natural river processes to reduce flood risk. We can give people advanced warning of a potential flood so they can get to safety, so they can protect their valuables. One problem with this is that not everyone will listen to this, and not everyone has access to the warning system, especially if it's internet based. You can zone floodplains so that building is restricted near areas that are at risk of flooding. This is going to be less effective in built up cities, and in the UK we have a housing shortage. Trees can be planted so we can have a reduction in surface runoff, and we can restore rivers so we have areas like wetlands for water storage. This can reduce the risk of flooding downstream. In this case study, we're going to be looking at the creation of the Jubilee River near Windsor. This is a relief channel for the River Thames. This is a very low-lying area. It is part of the floodplain for the River Thames. It is home to a large number of tourist attractions that bring in money throughout the year, and the Jubilee River was created to take overflow water away from these areas. When the Jubilee River was created, lower income homes were put at an increased risk of flooding. And this was done to protect tourist attractions like the castle and to the people that live in the areas of Windsor and Eton. This was a very expensive project to build, and very soon, within a year, the weirs were damaged and needed fixing. Since this has been created, there has been a large increase in downstream flooding in these lower income areas. There has been disruption to homes and businesses due to downstream flooding, and where the water has been moved, there has been a build-up of algae. Cherwell near Banbury, and this river is a tributary of the River Thames. There have been a number of devastating floods in this area in 1998 and in 2007 most significantly. To help reduce the risk, a management strategy involved embankment building along the river. Floodwater storage areas were created. The local road, the A361, was raised, and around it the drainage was improved. A new pumping station was also installed. All of this work created new roads, it created new footpaths, and it created new green space for the local people. It was expensive to build, coming in at roughly 18.5 million, but it is estimated that it provides £100 million worth of savings in potential damage. A reservoir was created in the area that they removed all of the earth from for the embankment, and a biodiversity action plan was put in place. A cup of tea might be needed for this next one. I know, teacher jokes, that's so hilariously funny. Anyway, we are now moving on to glacial landscapes. During the last ice age, the majority of the UK was covered in ice, and the melting of this ice shaped the physical landscape of the UK that we know today. As a glacier moves, it can pluck stones, so water freezes around loose sections, breaking them free, and cracks form for more water to seep into. Abrasion is erosion due to the rocks that are already in the glacier moving over the surface. And freeze-thaw weathering is when water freezes, it expands. This will crack the rock. When the ice melts, the water will move further down into the crack. It will freeze again and the cycle repeats. Large amounts of material can be moved over a long period of time. A glacier can move large amounts of material. It starts with ice forming. As the weight of this increases, the force of gravity will mean that it will start to move downwards. Uneven movement can cause cracks in the glacier, and meltwater will form and the glacier will move over the top of that. The movement means the surface under the glacier is eroded, and as the glacier moves further down, it begins to melt. As it melts, it begins to deposit debris. There are a large number of landforms which we can see are caused due to glacial erosion. There can be large hollows. These can have steep-backed walls, lips at the front, and often they are filled with water to form lakes. At the back of these, there can be knife-edge ridges, and pyramid peaks can be formed by erosion when things are in close proximity. Truncated spurs occur if ice cannot move around an area, then it will simply move through the area. Glacial troughs can be steep-sided, wide valleys. We can have long, narrow lakes, and smaller valleys are often called hanging valleys. There are a number of landforms that are formed by the deposition of glacial material. So we can have collection of rock debris. This can come from various different parts of the glacier. It can be underneath it, at the edges of a glacier, where glaciers merge together or meet, or at the end of the snout of a glacier. We can have large boulders that seem to be out of place or are in an unusual place due to location or rock type. And we can have smooth egg-shaped hills. Living in a glacial area can provide a number of opportunities. For example, tourism. Lots of tourists will visit the area to climb, to walk or to cycle. They may visit to view the wildlife or the culture. While upland areas have poor acidic soil, the land there can be used for grazing animals. And the flat bottom of the glacial trough can be used for growing crops. Conifer trees go very quickly on the soft acidic soil. This can be used for soft wood. And the uplands are areas have very good quarrying material. Lots of hard rock, limestone. But within all of this, there is going to be conflict. Quarrying will lead to pollution, which could spoil the landscape, affecting tourism. Tourism will cause a rise in house prices, preventing local people getting on the property market, and access to land can cause tensions with farmers as people think they can walk through fields of crops. New infrastructure is a good thing, but it needs land to be built on. Farming may come into issues with water use and reservoirs. In this case study, we're going to look at an upland glacial area, tourism in the Lake District. There were 15 million tourists in 2014. They mainly used cars to access the area, and interest in the area has caused high house prices. The local jobs are going to be seasonal and they're going to be poorly paid. However, tourists spend lots of money. This creates jobs and new business opportunities in the local area. Overcrowding of popular areas can have a significant impact on the local plant life and the local animal inhabitants. This can also lead to significant pollution as people drive there, and damage to farmland as people walk on there. They've put new roads in place, a park and ride has been introduced, and transport hubs where it encourages people to switch from their cars to bikes or to walking. A number of traffic calming measures have also been put in place. This case study is looking at the upland glacial area, tourism in the Isle of Arran just off Scotland. Now a large number of people that go to this area fall in love with it, and tourists move here permanently. This brings the average age of the population down. This is keeping the local schools open, bringing new infrastructure. However, there is a high number of injuries and fatalities, and the local search and rescue is staffed fully by volunteers. Tourists bring with them a large amount of traffic, but also new jobs and business opportunities. There is significant erosion to footpaths in the local area, and better drainage has been put in place to prevent these footpaths becoming waterlogged. Well done, guys, you have made it to the end. I am so proud of all of the hard work that you have been putting in.